How's everybody doing tonight? Good? Well, thanks for everybody for coming out. I know how it is leaving work at the end of the day, but a lot of us are getting into this space of blockchain and cryptocurrency and everything else. And this is kind of why we have these meetups. One, to make it easy for people that are new to the space to learn about it. Two, there's going to be a lot of people in the room that have experience around it. So if you are new, it's great to network with them and get a good perspective on it. That's kind of how I learned. That's how Sammy learned. I'm one of John Riley, one of the co-organizers, along with Sammy Elvar. So our thing is really invite people, include them in this space, learn about it. It's not to sell you anything, it's to educate people on it. We try to bring in speakers that have a background in this technology so you can learn about it, but also give you an opportunity to even talk with them afterwards and say, hey, can you help me understand this more? And then ask us questions. Because the more you come to the meetings, the more comfortable you're going to be in learning about the technology. So when you leave it and you go home, you're going to look it up and Google it yourself and saying, you know what, somebody talked about this in cryptocurrency, or why is that blockchain platform tied to that cryptocurrency important? And this is the big understanding. The more you understand it, then you can make, okay, wow, now I know what they're talking about when they mean this. Or now I know what, like tonight, what smart contracts are. So really, it's really give you an overview. And if you have any questions, you know, there's a lot of people in the room that can help answer it. You know, Jason tonight, Jason Shavelson, is going to be presenting on smart contracts, so I'm going to have him come up in a minute. And another thing, we also offer that people that are in the room, and some I'm going to pick, we like to have presenters at some of the meetings. So the next one, we're going to be picking some people to present. Because it's really, there's some great people with a lot of insight. And for me and Tammy presents as well, it's great to hear that people that have a great passion around it and that have been in the space, because then you know what they're talking about. And they're not just, oh, I just read this on Google, so I'm going to go and talk to everybody about Ethereum. It's like, no, you'll know in the past when they start talking about it, they won't be able to shut up. That's when you know it's real. And that's what I like.
Just tell me to shut up.
No. But those are the people you want to
look at you directly.
So,
I
don't know.
But you want that. You want that, because then you know it's real. It's not like, oh, maybe I'll take it. You know, a lot of us that are in the space, we can't shut up about it because we're excited about it. And it's still so new for some of us. It's still, you know, I look in the US, it's a year behind what other countries are doing. But knowing we're in the space now, it's going to make it so much easier when everybody's like, I want to jump in the pool with you. They're like, I've been here for a year. They're like, you know, I know what we're talking about. Then you can educate people. Yeah, this is what it is. This is what Ethereum is. This is what Bitcoin is. This is what, I'm talking about cryptos like ARK and Civic and Stealth, and it'll go on. It runs the gamut. So hopefully you get some information tonight. If you have any questions, don't hesitate to ask myself, Jason, Sammy. There's a lot of great other people in the room that can help out as well. So Jason, I'll bring you up.
All right.
I'll let Jason present.
Thank you. Spacebar? All right, do I get those too or no? That's all right, I'll wing it. So, hello everybody. My name is Jason Shavelson. I'm very excited to be here. Thank you, John and Sammy, for putting this together. First thing I want to mention is I saw a couple guys in the audience, one with a Bitcoin sock, and another guy with Monopoly socks. I love it. That is awesome. So just a little bit about me. I've been in software for over 20 years, from a developer to a manager or an architect. I mean, I've pretty much done everything there is to do when it comes to development, every language out there. I teach programming at Nova University to biomedical engineers, specifically Swift programming for iOS development. I don't program as much professionally anymore, but I actually manage people that do programming. But I do program on the side, and I've done plenty of Solidity programming, and I have also a couple of guys on my staff that do Solidity programming as well. As John said, it's a very, very exciting space. I am extremely passionate about this space, and I'm very excited to be sharing some of the stuff that I've learned over the past 2-3 years from doing this. As it says, healthcare and fintech is really where I've been focused on for most of my career. I don't know if you guys know Miami Children's Hospital. I managed their whole web development team, as well as HCA, which is one of the largest healthcare providers in the country. I was their director of software dev there. So before I start, I went around and I talked to a few people here, and I kind of gauged, what everybody's kind of level of knowledge is. I just want to ask a couple questions so I know how to focus my presentation. So I assume everybody in here knows what blockchain is, right? Yes. Okay. Perfect. How many programmers do we have in the audience? Uh-oh. All right. So I got to be honest now. All right. How many people that are trying to learn how to program do we have in the audience? Anybody? No. Okay. A couple folks. Wait, you raised your hand twice. No, you know what? That's a great point. I mean, the more you know, the more you realize how little you know, right? Especially when it comes to programming. So, all right. Well, I'm going to try to keep this as high level as possible. I'm going to get a little deep not too deep into the code. I'm going to give you a little background on blockchain. I'm going to try to, I'm sure a lot of you folks have read plenty of stuff that's out on the web, so I'm going to try to give you a couple of nuggets that maybe you haven't heard or maybe you haven't found. So this is kind of my starting point as far as what I want to cover in the next few slides. I'm very fascinated by Satoshi Nakamoto and this whole concept and who this guy is. And I don't know if a lot of you guys know, but the blockchain was around before Satoshi's white paper. There's a lot of speculation as to whether the same guys that started blockchain back in the day are actually Satoshi Nakamoto. There's been a lot of speculation in the past few years that it could be Jeff Lubin or Nick Szabo, or a combination of those guys, or there was some guy out in California, I think. Was it California? An Asian guy. His last name was Nagamoto. And he lived within a few miles of Nick Szabo. So some people are speculating that Nick used this guy's name, and it's very chaotic. But for me, it's part of the allure to this whole space. I don't know about you guys, but that whole mystery around it, And if somebody actually came up with this fictitious person to really kind of make people excited about it, wow, that's pretty cool too. So not going to spend too much time here. We know he created the white paper for Bitcoin, right, which is based on the blockchain, solved the double spending issue, which is very interesting. I have Solidity on here. I don't know how many people know what that is, but there have been a number of people that have been trying to figure out who this guy is. And they've been trying to use a method called Solidity, which is a method of looking at all of your online postings and then breaking those into certain chunks that form patterns, and then comparing those patterns to other online postings to theoretically trace back to whoever originated that, right? So it's like a fingerprint, okay, of sorts. The kind of amateur people that have done this, some people have pointed at Nick Szabo. I read an interesting article recently, which I wanted to share with you guys, that some people believe that the NSA already knows who this guy is. And the article I read gave some very interesting points, because they said that the Obama administration directed the NSA to figure out who this person was, because they were concerned that this person was a foreign agent and that this new technology may somehow disrupt or hurt the United States. So the NSA actually used the same method, Solidity, to identify this person, so the article says. What they have to their advantage is a lot more data than these amateur folks. So there are some people that do believe that the NSA does know who this person is, but will not release their name. All right. So what is blockchain? It's a decentralized ledger system made up of blocks and that are cryptographically secure. I think most of us probably read that over and over and over again. It's made up of nodes. I'm going to talk a little bit about distributed databases, mining, proof of work, and it's also a deflationary model. So I put this slide up here to show where we are and where we want to be. This is a typical client-server model. The lines aren't coming up, but there are lines that are pointing to that main server in the middle there. And on the right-hand side, we have the peer-to-peer server model, which was made famous by Napster. I'm sure some of you guys have heard about Napster in the past. And what does this do for us? So take, for instance, imagine that this central server is your bank, okay? And all of these clients around are people that use this bank as their place to deposit their money. Well, today, the banks do distribute their servers over multiple areas, but most of the data is still centralized into these servers. So it makes for an easy attack point for hackers, okay? The other thing is the immutability of the blockchain and being able to modify the data and knowing whether or not that actually happened or not, okay? On this type of system, it's very difficult to find out whether or not this data was modified. It could be manipulated by many people, the company, the bank themselves, okay? In this peer-to-peer model, what we've done, or what blockchain has done, is distributed that data across multiple nodes on the network, okay? And what that does for us is it prevents or decreases the hacking potential. So the data is now stored on all these different computers around the world on the network, and in order to hack that data would take a massive attack. And I think it's the 51% rule, right? So it would take 51% of the network to be bad nodes to actually be able to modify that and disrupt the blockchain. Satoshi's white paper suggests that that's impossible because of the exponential growth of the network itself. That is starting to come into question today because of mining, and we're going to talk a little bit about mining in a moment. But these mining farms have become so big, there's countries that are throwing money into these mining farms. So that is starting to raise another concern for Bitcoin and the blockchain, that there are some people that are developing such large mining facilities that they could potentially disrupt the blockchain and modify the actual blocks. So something to definitely look out for. Mining. So I think that this was a brilliant concept. You want to create this decentralized network. And you have this idea, but you have no nodes on the network. How are you going to create these nodes? How are you going to build this conceptual model that you have in your head into this global network, right? Well, what Satoshi's white paper has done is suggested mining. Not suggested, he's actually implemented it. And what mining does is it incentivizes people to create nodes on the network because there's a monetary return for them. So these miners basically set up a computer, okay? There's a couple of different ways to mine, CPU or GPU mining. We'll talk briefly about that. And these miners take transactions and they have to complete a very complicated mathematical problem in order to process that transaction, okay? And for doing that, they get Bitcoin. It started at, I believe, 50 Bitcoin per block. Now it keeps halving every few years, or 6 years it is. It went to 25, but we're now, I think, 12.5 Bitcoin per block that is mined. That's going to go down to 6. And then in 2021, I believe it is, all of the Bitcoins will be mined at that point, and that's where the deflationary model comes in. So today we have a system, especially here in the United States, of a fiat currency where people can print money, or the government can print money, and that can lead to deflation. This is a fixed set of monetary value that can never grow bigger than it is. So it's theoretically supposed to prevent deflation, or inflation, excuse me. Let's see, CPU versus GPU mining. CPU is obviously central processing unit, GPU graphical processing unit. CPU mining is typically used on the Bitcoin blockchain. You're seeing companies that are actually making tons of money on CPUs and also video cards. So GPU is another way to do it, which is the graphical processing unit. And video cards are like selling through the roof. NVIDIA's stock has gone nuclear, and if you want to try to get into mining, it's very difficult to find the parts these days. That's a little bit about that. Mining pools have started to come into existence. So for somebody that wants to get into mining, it's going to be hard to compete with some of those other folks out there. So they have these mining pools where you can join and you can submit your computer as a resource to pull power from, and you're doing it with a big group of people. So you're not going to get that 12.5 Bitcoin. You're going to probably get a fraction of a Bitcoin, but it allows you to compete in a space that has grown to a place where it's very difficult for the small guy to actually get in and do it. All right. There are definitely a lot of energy consumption concerns around Bitcoin and blockchain. Those need to be dealt with, or else this is not going to work. There are a lot of people that are trying to figure out how to deal with that. And proof of work, which is a consensus model, may not be the best way to go, which is the mining model that I was just discussing. So there's some other models that will hopefully address that. Okay. So what is a block? A block is a number of transactions that are held within a container, basically. What makes a block unique is a hash key that connects it to the previous block. Okay, so that's what creates the chain. So when you hear blockchain, it comes from the fact that you have these blocks that contain transactions, and you have what's called a hash key, which links them to each other. Okay, so if anybody were to try to manipulate the data within the blocks, this hash key would not match up with the previous block. And what happens is once a transaction is sent on the network, it doesn't automatically get approved. It has to go to a certain number of nodes before the network says, all right, you know what, this is legit, and we're going to go ahead and append it to the blockchain. Okay, so that's where some of the immutability comes in, and the prevention of kind of fraud and manipulation of the data. And I'm really kind of striking on a high level. I don't want to go too deep into blockchain. I mean, we can get into cryptography and all kinds of things, but I think that's a little out of the scope of this conversation. Some of the advantages of blockchain, and right after this, we're going to get right into Ethereum. I just wanted to make sure I level set everybody. Transparency, so public blockchains allows everybody to see what is on that blockchain at any time throughout the course. There are private blockchains, and I had a nice discussion with a few of you before regarding that. Reduced transaction costs. This is an interesting topic because right now it is actually very costly to transfer Bitcoin in and out of fiat currency, and there's some transaction fees that are kind of exorbitant at this point. The theory behind the reduced transaction cost really is where the beauty of the blockchain comes in, is removing the middleman. Okay, so take for instance, I have a bank, I deal with Wells Fargo, and I want to give some money to John, and he's got some service that he is going to offer me, and he's got, like, let's say a Square, okay, on his phone. So he takes my credit card, he runs it through the Square. It first goes to through the Square software, then it goes to a processor, then it goes to my bank to grab the funds, and then finally transfer it through a clearinghouse to John's bank. So there's a lot of intermediaries in that process, and each one of them are actually taking a piece of the pie, which is elevating the cost of the goods that we have today. So theoretically, if we can remove some of those middlemen, we can reduce the costs of some of these transactions, and that's one of the hopes that Bitcoin and cryptocurrencies and blockchain will meet. Faster transaction settlements, that is part of it. Removing the middleman. I don't know how much you guys know about Ripple and the SWIFT exchange, which is an international exchange of money. SWIFT can take up to 3 days. If I want to transfer money from here to, let's say, somewhere in Europe, Italy, or whatever, it could take up to 3 days to have that clear, that transaction. Well, Amex has teamed up with a bank and also Ripple, which is one of the cryptocurrencies and technologies, and they've been able to do that in 2 to 3 seconds using their technology. So it's definitely sped up the process quite a bit. Financial inclusion. Oh, no, let me not forget user-controlled network. So that's the other part of the peer-to-peer network, which is the power of the network is really controlled by the users of the nodes on the network. So we're going to talk about some use cases, and I'm going to show you some other companies that are actually using this. One in particular is a kind of a copy of Twitter. And you know, Twitter today has the ability, and countries have the ability to censor Twitter. Well, with this type of model, it would be very, very difficult to censor tweets, because that data is distributed across the world on so many different computers. Today, let's take China for instance. China, for one reason or another, doesn't want to allow Twitter to participate or be available within its country. And I don't know that that's true, I'm just using this as a hypothetical example. China can block all of the Twitter servers, and that's it. Nothing comes into that country from Twitter. Of course, there are workarounds, but that's more technical. But with this kind of structure, this peer-to-peer structure, there's so many nodes on the network, it would be very, very difficult to block all of them coming into China or any country. Financial inclusion, there's a lot of folks that don't have access to bank accounts for one reason or another, credit cards. You know, I don't know if you guys got caught into the catch-22 when you're a teenager here trying to get a credit card without credit. It's not easy. You got to establish credit. The blockchain and Bitcoin can help in that area, and in some countries it already is, especially in Africa. All right, so now the reason you guys are here. I hope I didn't bore you too much. So Ethereum is another decentralized blockchain. It's open source. The difference between Bitcoin and well, there's many differences, and the blockchain that Bitcoin is running on is that this has a programming language that you can write against it. Also, Bitcoin has its own closed blockchain, meaning that it was developed for the Bitcoin, right? This platform allows you to develop whatever you want on its platform. So you don't have to create your own blockchain if you have an idea, okay? The other part of it is the smart contracts, and the smart contracts are a mechanism to program against Ethereum. Okay, let's see. We're going to talk about DApps. DApps is distributed applications, which is basically when you put an application on Ethereum, it's distributed, like I said, across all the nodes on the network. And I just put up here when I wrote these slides, Ether was up. The Ether supply was about 98 million Ether was out there, and the market cap was approximately 81 billion. That may plus or minus on that, depending on how the market is today, but it's gaining some traction. $81 billion market cap is, I believe that makes it the second or third largest cryptocurrency right now. Potential use cases. So digital identities, voting systems. Again, you have the transparency, the immutability. You know, digital identities is very near and dear to my heart because I come from the healthcare space. You take, for instance, in the healthcare, you go to a different healthcare space, you go to a doctor, you have to fill out forms with all your information. They have your records at their location, and you go to another, and your stuff is everywhere, right? Well, this theoretically could create a digital identity for you, and you could actually be in control of those records a little bit more than you are. So you give a doctor access to submit to your records, okay? And then if you need to provide those records to another doctor, you give access, you allow people to have access to that data. One of the things, one of the scenarios that I like to give is when we go to websites and we want to use a service, oftentimes we have to sign up for that service, right? And each time we create a new password, we have to enter our name in, address, phone number, whatever it is, over and over and over again. Well, guess what? Those companies are going around and they're taking your identity information and they're reselling it for a profit. You don't know where it's going, and you're probably going to get flooded with emails, phone calls, and things that you really don't want to do. So this digital identity would hopefully prevent some of that from happening. Voting systems, the immutability part of the blockchain is what's very attractive for voting. So, you know, we had this whole Russian scandal that's going on, and now I heard a couple weeks ago that there was definitely some penetration into some of the voting machines. Of course, it didn't affect the election according to the article and the higher-ups in those organizations. But this is another technology that would prevent and eliminate a lot of that. Crowdfunding, escrows. I talked to somebody about real estate just a few minutes ago. Logistics, very cool example. Walmart, the CTO of Walmart, challenged his staff. He basically came in one day, gathered his staff, he brought them in his office, and he had a basket of avocados. Put the avocados on his desk. He says, I want all of you to track these back to their original source. So they came back, I think it was about 7 or 10 days later, and they were able to define the source of where these avocados came. But there was a lot of legwork involved with that. The blockchain would allow you to do that in seconds or minutes if it was implemented correctly. Okay? DAO is decentralized autonomous organizations. So this is really kind of a purist view of blockchain. You know, there's a lot of people, the purists really want to take the control away from the governments and put it in the hands of the people. The governments right now are fighting that pretty hard, and that's a lot of the volatility you see in the market is because of that. Some of the things that governments are doing, shutting down exchanges, you know, preventing people from transferring money in and out, a variety of things. So it'll be interesting to see how that pans out. All right, did we skip some slides here? No, we did not. All right, so some notable DApps. I was talking about the decentralized Twitter. There it is, ETH tweet. We talked a little bit about digital identity. There's a company called Uport. These are all actually live projects that are available today as distributed applications. Etherlance, so this is a free marketplace that you can buy and sell things. You have LivePeer, which is a video streaming service. Safe Market is also a free market system. And then CryptoKitties, which I was talking about earlier, which was released, I believe, in November of last year, and it was one of the first gamified DApps on the market. It got a little bit of flack because it was partly centralized, but I think that, you know, the people that really understand blockchain really know that there are certain use cases when you want to use blockchain and others that you don't, okay? And putting all of that information onto the blockchain is not going to be efficient today as the technology is today. So I believe that a nice hybrid approach between a centralized database and putting information on the blockchain in most scenarios is the way to go. Now, I want to caveat that with most scenarios. There probably is, I'm sure there are scenarios where, you know, you're dealing with smaller data sets that you could put on the blockchain and not necessarily affect efficiency. All right, so Vitalik Buterin, really interesting guy. I did some pretty serious research on this guy, and when I started, and just was amazed by how smart he was. You know, this guy was born in Russia, moved to Canada with his parents at age 6. His father was a computer scientist. He was figuring out 3-digit addition problems in his head, like at age 10, faster than any other kid. But what I really found interesting is he went to this private high school called Abelgard, I believe is the name of it. And they use what's called the Socratic method of teaching, which is a productive discomfort is what that is. And it's a form of developing critical thinking where you're actually really, you're not just taking what, you know, here in the US, we read a book and that's the gospel for the most part. Here, this high school that he went to really makes the kids question everything that's in the book. And the teachers are taught to ask uncomfortable questions, which to me was really kind of enlightening because I think to myself, and I'm like, you know, back in school it seems like, you know, everybody was coddled and, you know, oh, you don't know the answer, it's okay, and we'll ask somebody else. But then you get into the business world and it's like, you know, what's this, what's that, what's this? And if you don't know the answer, you're sinking fast. So, you know, teaching that at a high school level I thought was just brilliant. So he co-founded Bitcoin Magazine in 2011, wrote a white paper in 2013, and then he came down to all places South Florida to the Bitcoin conference in Miami, which John, Sammy, and myself were at a couple weeks ago, which was great. This was back in 2014. He announced Ethereum. And then, actually it was before the conference, a bunch of people that he had been talking to moved into a loft down in Miami, and just basically they had bunk beds and they were all programming together. The cool thing about this, which I think is really cool for all of you, is the original founders of Ethereum met at a meetup. So Vitalik actually went to a meetup, a local meetup in Toronto, I believe it was, by this guy named Anthony DeLauro. And Anthony DeLauro was a serial entrepreneur that decided to start this meetup group out in Canada. And Vitalik showed up there one day, and after the meetup, sat and talked to him, and they really hit it off, and they went into business together. And this DeLauro guy, Anthony DeLauro, actually funded the project early on and had them all come down to Miami. Things broke up a little ways down the road, but it was a great start. And the fact that they met up a meetup, the power of meetups is really there, and I witnessed that myself. One of the people that a lot of people don't know of is Dr. Gavin Wood. Now, there was a lot of other people that were involved in Ethereum, but Dr. Gavin Wood really took it to where it is today. Or not today, but he really took Vitalik's conceptual idea, which was detailed in the white paper, and then he created what was called a yellow paper. And that was a document that actually outlined how to actually make the conceptual idea that Vitalik came up with. And so he created the EVM, which was the Ethereum virtual machine, which is a way to take programming code and then compile it on the fly and make it do something, okay? So he was the brains behind that. He also was the brains behind Solidity, which is the programming language, which we're going to talk a little bit more about shortly, to write smart contracts against Ethereum. So this guy is super smart. I put some of the other Solidity programmers up there because I felt bad when I was making this slide. I'm like, there were a lot of other people that participated in this. So this is really only a subset of the folks. At some point, Dr. Wood paired off from Vitalik. He created his own company called Parity Technologies. It's one of the early Ethereum consulting firms. And he's working on a product now called Polkadot. And somebody asked me today about switching coins between different blockchains and things. And that's kind of one of the holy grails that people are trying to focus on right now. I know John and I talked to WanChain, and I think there's another one called Arc. Well, Dr. Wood is developing a similar one. It's a platform that will allow you to exchange currency or tokens on any blockchain. So whether you're on the Ethereum blockchain, you're on Hyperledger, you're on whatever blockchain it is, the Ethereum blockchain, he wants to put together a platform that will allow you to transfer currency and tokens from one blockchain to the other, which will then make it a much more homogeneous kind of network, which will be good in the long run. All right, so jumping right into Solidity. So Solidity is a fairly simple language for developers. It's very reminiscent of JavaScript. As a matter of fact, they followed the foundational standard for JavaScript in order to create this. Okay, and it's kind of a self-governing type of piece of code. The thought here is, there are many things that we do that we go to services for that require people to say yes, no, give you money, this, that, the other thing. And I'll give you an example. In real estate, when I went to buy my house, and those of you that have a house have gone through this process, you've got two real estate brokers, you've got a mortgage broker, you've got insurance, you've got notaries, you've got lawyers. I mean, the list goes on, right? So what these contracts aim to do is kind of take that out of the picture. Why do we need it? These people follow matrices and a set of rules in order to do that. So why not just make that a smart contract on a network and eliminate the need for those people? Now, those people aren't going to be too happy, but this is what's going to happen. This is what's going to happen. There is the argument that, well, doing it this way is very rigid, and that's a valid point, right? So when we negotiate as human beings, or we think about entering a contract, oftentimes there's negotiation that goes on, right? Oh, that price is too high, you got to lower that price for me. I mean, come on. So those types of things still need to be felt out and figured out, but the rigidity of these smart contracts is also attractive as well, because if it's me or you or whoever it is, we're being held we're being dealt with the same way. And not because of the way we look, how much money we make, or whatever else it is, we're being treated differently, which kind of happens today in our society. This is looking to kind of eliminate some of those things. Okay, so I have a simple smart contract up here. You really can't see it too well. I don't know, I guess it's the projector. Wow, it's a shame. All right. Yeah, I'm going to try to show that in another way. John, do you know if we can make this a little crisper? I can't actually see any of the code. No?
There's a little contrast.
Maybe we set the contrast too
Turn the
high.
lights on, maybe the contrast is too high.
Yeah, maybe it's just auto adjust.
Yeah, I think we're getting to the interesting part now that I rambled on for 20 minutes and we need to see it.
Does that help?
Turn off the front one.
No, not really. I'm wondering, can we make this darker here on the computer? And I don't.
That's not going to change the
Contrast factor zero.
Technical difficulties, bear with us.
Do you have it as a text file so you can open it and edit that?
Yeah, I'm actually going to bring it up in one of the editors in a minute, but I don't know if that would show up there either, so.
It looks good.
It's better.
That's
It's
much
much
better. All right, so this is a very, very simple contract. It's got a couple of functions. At the top, you put Pragma Solidity and the version number of the Solidity that you're targeting. Currently, .11 is the latest version. And then it's basically a storage contract, and what it's doing is storing a number. Okay, I really wanted to kind of make it very simple. You have an unsigned int. We created a local variable, and then we create two functions of set and get. Right. So how do we set? We set a number to that variable, and how do we get it back out? Okay. And I'm going to show you. I can show you actually a working copy of this. The other thing, before I get into that, I wanted to show you or talk to you about was the token standards. So early on, Vitalik and Dr. Wood decided they needed to have a standard for creating these tokens. As I stated before, blockchain had a specific purpose for Bitcoin. Vitalik's kind of vision was to create a blockchain that would allow you to create any type of token, voting system or application, whereas blockchain was really kind of confined to Bitcoin. This was a platform that would allow you to build all kinds of different things. So we came up with a standard for the token. It's the ERC20 standard. There's a variety of standards out there now. They go through a peer voting process, and there's a bunch of them that people are trying to add. There's ERC 725 and 735 that adds additional metadata to the coins, so you can pass additional information with those coins along. So it's still kind of a moving target. These standards are still being developed, but this is the base standard for the tokens on the Ethereum network. You can see the functions, very, very kind of simple functions: the total supply, balance, allowance, transfer, approve, transfer, and then the events when these things happen, so that any kind of front end code can catch that event and actually act on it. Everybody has an address. If you have a wallet, which I'm sure many of you do, you have a hexadecimal number that is an address that is associated with you and your wallet, and that is how people can send money to you, right? So you can see that we're passing addresses in and out of these functions in order to do that, and that's how we transfer things around. So just quickly talk about development stack. There are a variety of ways to develop on Solidity. There's also a couple of other languages out there, Serpent being one of them. Really, Solidity has been the most prominent and best, and the one I would suggest for anybody that's trying to get into blockchain and Ethereum program. Definitely do Solidity. And so at the top, I've got a couple of different Solidity development environments. Remix is really kind of the first place to start. Okay, it's an online web-based development environment. It compiles on the fly, and then you can actually run the contract and interact with it. And I'm going to show that to you in a moment. I've been playing with recently Visual Studio Code. So I'm an old Microsoft programmer, .NET guy that's used Visual Studio for years and years. And I found out that they have this kind of really pared down IDE, Integrated Development Environment, excuse me, I'm using my acronyms. But it's a very simplistic editor that can be used for any language pretty much. There's plugins or libraries that you pull down, and it changes the highlighting of the text automatically, and it also gives you context-sensitive help. Context-sensitive help for the non-programmer. When you're writing code, you can't always remember all the functions and things that are associated with the framework you're using, so context-sensitive help as you're typing gives you little reminders and allows you to see everything and then not have to remember it, and you can just select it and bam, there you are, you have your function. Truffle framework. So the Truffle framework, I think on their site they coin it as the Swiss Army knife of Ethereum and Solidity development. They do a variety of things from auto code deployment, code checking, testing, automated testing, a variety of things you can do with Truffle. That is something is a little more advanced as you kind of progress in your Solidity programming, something I would definitely take a look at. Test RPC, that's basically a testing tool that allows you to submit transactions and play with Solidity and your contracts on a local environment. And then front-end development. Now, the front-end development, you can use all kinds of different front-end technologies. The ones that I'm using right now, I'm using React. We are doing JavaScript stuff. Every once in a while we'll play with .NET, but really my front-end programming language right now is React is one of the ones that I'm really kind of high on right now, and my team is starting to use pretty diligently. It was developed by Facebook. It's a fairly simple language, also very JavaScript-esque, if you will. And one of the really cool things about it is they have React Native, which allows you to develop using this same language and develop native applications for iOS and Android. With really, it's the programming language, there's very minor differences. It's really about the controls that you're using, but otherwise the language is pretty consistent across the board, which makes it really, really easy for a programmer to get up to speed and develop all different kinds of apps, So I really like that. JavaScript, for any web developer, you guys know what that is. Guys or girls, I don't want to sound sexist. And then the Web3.js library. So that is a library, an open source library that was created. It's a JavaScript library that allows you to interact with the Ethereum network using JavaScript. It's the way to go. It's the simplest way to actually interface with the Ethereum blockchain. Node.js, that's another kind of middleware piece that I like to use for creating APIs for the front end. So I'm not going to get too deep into that. Most of the programmers probably know what that is. And then you have the browser. So this is kind of the interesting part. In order to interact with the blockchain, you have to have an active wallet with some Ether in it. And you actually have to have a browser and an application to deal with that, to actually manipulate things. Well, in order to make that link right now, okay, you have to either use a MetaMask Google plugin, okay, and I'm going to show you that, or you can use the Brave browser or the Mist browser. Okay, the Mist browser allows you to have a wallet, create contracts, as well as MetaMask does not allow you to do that. Brave browser I haven't actually played with. I pretty much use MetaMask for the most part for most of our development, and I'm pretty happy with that. So let me quickly show you what a contract looks like in Remix. Oh, you know what? I'm not doing this on my computer, so
That's the Brave browsers.
What's that?
That's the Brave browsers.
Oh, is it?
I have something up.
You know what? I didn't even think about this. I should have done this from my computer. I had it all set up. Do you have a working? This is just the basic ballot.
That's,
Yeah, this is the standard. What's that?
That's the default one.
Yeah, it's the default one, I know. All right, well, let's see then. So you're gonna put some pressure on me? Let's do it. Let's do it. Actually, you know what? I don't wanna waste anybody's time. I'm just gonna copy and paste, because this is what I had. Oh, here we go. And,
Do you need an HDMI adapter or something like that?
let's see if we can wing it like this. I don't wanna pause again. I think we can figure this out. And just create a new file here, and we'll just call it storage.
the keyboard is very.
Oh yeah, I see that. Storage. You guys throw me all kinds of curveballs here. All right, let's see how it is.
Why, you're thinking your toes.
What?
You're thinking your toes. Hey, Jason, why are you doing this? Does anybody have any questions so far for Jason? When it comes to smart contracts, what is that now?
All right.
All right, that's not bad.
Okay, so you have a wallet here with Ether in it? I'm gonna plug my address right in.
I don't have MetaMask on my 3, but I have a.
But it'll bring up the wallet anyway once I open the contract, right?
Yeah, it should. It'll ask if you want to use MetaMask, and it'll probably say install. If you want to just click install.
Oh, let's see. I mean, if I want to just create this real quick, I would come here. But you're going to need. Yeah. So I just submitted the contract. This is on the JavaScript video. Okay, really. I should probably do this on my box, but. All right. Well, let's see if this submits. So no, it's got one pending. It's got no pending transactions. Creation of ballot pending, but it doesn't show it there. Yeah, let's pull out my laptop real quick, because I had this ready to go. Apologize. Didn't think about that slide where I was going to show you actually how it works.
HDMI, VGA adapter?
Yeah, I'm going to need an
You can do
HDMI.
AirPlay. Or you can do AirPlay. As long as you're on the same Wi-Fi. You can connect to it.
Yeah. Well, then I got to set up the Wi-Fi and the whole bit. Do we have an HDMI plug? Okay. You with me on the Wi-Fi? All right, so I don't need this stuff.
Jason, while you guys are setting up, what's the difference between the Ethereum and Ethereum Classic? I know the
good question.
I know the original hack, but right now
question.
It is a very good question. Yeah. So yeah, for those of you that don't know, there's Ethereum and there's Ethereum Classic, and I believe it was in 2015 there was a major hack of a company called the DAO, which I mentioned earlier, a decentralized autonomous organization, which was kind of this concept. Well, this company took that name and made a company out of it. Long story short, they were hacked for $50 million. Okay, and what happened is that the Ethereum community was at odds as to how to handle that. There were some people on one side that said they wanted to fork the network and get that money back for the people who lost that money. There were other people that said that defeats the whole purpose of the blockchain. That's not what the blockchain is supposed to be. And so you had these folks that were on two different sides of the equation. Vitalik was on the side of forking. Fork is basically taking a code base and then modifying it either to your own liking, changing things, or whatever you want to do to it. So Vitalik decided he was going to, and his group of people, that they were going to fork Ethereum in order to get that money back. The other group decided, you know what, screw that, we're going purist, and we're going to keep the current blockchain that we have. That's why we now have two Ethereums.
What's the difference now, though? Besides, are there any major differences besides the split?
Not really at this point. No.
Ethereum Classic is
The programming is the same.
Ethereum Classic is just the original chain that has
Yep.
never been changed, even regardless of the hack that happened.
Correct.
Ethereum is the chain that
With the 50 million back
Yeah.
to the people that owned it.
Got you.
So,
But
curious.
it'll change in the future though, because if Ethereum goes proof of stake and Classy stays proof of work, that's
Yep.
a major difference.
You are absolutely right, and I think that is going to happen. I think, the proof of stake is going to happen for Ethereum, so we'll see. We'll see. It'll be interesting. All right, so let me see here. Get my presentation up, and then I'll have my links, and we will be good to go. Oh, you're going to see my son, I miss you, mommy slides, so just ignore those. He likes to get on here and just start doing stuff, so. All right. So let me just get there. And there we go. All right. Sweet. So this is the simple contract that we just discussed. Okay, and I'm using MetaMask. This is a Chrome browser. MetaMask is a plugin. Okay, it's right here. So I need to just quickly log into my MetaMask account. By the way, if you forget your password, you're pretty much screwed. And I have forgotten it.
You just gotta fork Ethereum if you get your password.
There you go. Look at this.
You just send an email to Vitalik asking him to do it.
To do it and he'll do it. And
JC
fine.
being right. Yes, I see that. Gotta love download, right? What's going on? Come on! I swear this is the password. That caps lock on?
Yeah, there you go. Maybe your keyboard is messed up as mine.
Give me your password, I'll try it here and see if it's working.
Yeah. You know what? I have been holding my password for my kids for the longest time.
You figured
And
it out?
finally, I broke down because they just annoyed me so much. And then what does my son do? He goes and just... La, 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 la. So I'm very careful of that. I swear this is the password. Let's try this. There it is. I used the more complicated one. Cool. All right, so now I've logged into MetaMask. This is basically just a wallet that shows you how much ETH I have and all of the transactions I've made and all the different tokens that I would have. This is a test account. You can see up here at the top, this is the Rostopin, I don't know how to pronounce this, Rostin test network. How do you pronounce it?
I don't know.
I know. You know what? There's so many different weird names in this technology that I tried not to say them because some of them I don't even know how to pronounce, but I know what they do. So you see you have the main Ethereum network, and these other ones are test networks, or you could use something like test RPC to do locally. We're going to just use Rostin. One of the things when you start with a test account is you have to actually put money in your account. You can't do anything without money. So they got something called faucets. So if you go to faucet.robskin.io, I think it is, IO, yes, you can actually get free Ether in the test network. Okay, so that's what I've done here. All right, so I'm logged into MetaMask. So what I'm going to do now is I'm going to create this contract on the test blockchain, okay? And it takes an input field. Oh no, that's my other one. All right, forget that. I'm going to go ahead and create it. All right, so it says down at the bottom here, creating send transaction failed, invalid address. If you're injected by please below, what happened? Give me a moment. There's the top. All right. So let me get my address here. Hello. Why is this not? Oh, maybe I just need to refresh because I logged in afterwards. Let's see. Yeah, there it is. All right, good. All right, so I just hit create. So the first thing that's going to happen here is it's going to go to my wallet and say, hey, in order to create a contract, you got to pay, create. By the way, I didn't get into that. Why do you have to pay to use this network. So this is one of the concepts which I think is brilliant, but it also bothers a lot of people. So for every transaction you do on the blockchain, there's a cost associated with it, Ethereum, okay? The reason for that is to prevent spamming, okay? So think about it. If you have a service, an application, you know, have you guys heard of what DDoS attacks are, denial of service attacks? Well, it's very easy in the current client-server model to pull those off, okay? It's a lot harder in the peer-to-peer environment to do that. However, it's still doable, okay? But what they've done is they've said, okay, we're gonna charge you each time you make a transaction. And what that does is it kind of prevents people, or theoretically prevents people from wanting to do these types of attacks because it's gonna cost them a lot of money. And then most likely on a peer-to-peer network, if they try to do a DDoS attack, it's not gonna work. So that's one of the reasons they charge for transactions. The other one is for code efficiency, okay? This is a way to promote code efficiency. If you don't write good code, it's gonna cost you more money. So the better code you write, the cheaper it's gonna be. So I think it's a brilliant concept. You know, some people are like, well, I don't have to pay for my website to do this stuff today. Well, no, that's not true, you do. Right? You're paying for hosting, you're paying for a variety of different things, your credit card processors, whatever it may be. I mean, you're still in a decentralized or centralized model, or in the hybrid model, you're still gonna need some web hosting. So these costs are pretty interesting, but it is one of the facets of the blockchain, and I think the concept itself is really solid. Is it going to be cost effective for us to develop applications on and still make money on? You know, that's still to be determined, I think, in some aspects. I think depending on the consensus models that are being developed or being used for different blockchains, that's going to change. So it's an interesting area to keep an eye on. So I'm going to go ahead and submit this. This is actually costing me $108,000. What is that? $10,856. Wow, I can't. Oh, wait a second. You guys can barely see it. Even worse. Anyway, that's in what's called, and here's another one of those words, which I'm not sure how to pronounce, but it's we, which is actually a subdenomination of Ether. Because of the value of Ether, they decided to make a smaller denomination. And so that's actually a fraction of a Bitcoin, of an Ether, excuse me. So I'm going to go ahead and submit this. You can see up at the top, it said new contract. It's creating this contract on this test network right now. So it's actually going to take a couple of minutes to do. So that's one of the things, right? These things propagate throughout the network. As they're propagating, they're being evaluated, and after a certain number of verifications, it gets appended to the chain. Okay, and so we'll just have to wait for just a moment. You'll see up here it says one pending transaction.
So is it waiting for the block right now? The next block?
It's waiting for the next block to be mined and processed. Yep, that's exactly what it's doing. And as soon as that comes up, we'll actually have the contract available to us here in this web browser.
So you mentioned the code efficiency.
Yes.
How does it measure code efficiency? Is it the size of the code?
Yeah, it's the size and the processing power that it uses. So if you put a for loop together, a loop, and it's an endless loop, that's going to just consume the storage.
Yeah.
What's that?
Storage too. That's what you're
and
paying
storage
for,
too.
storage.
Absolutely.
Yeah.
So you know, it's all about trying to make your code as efficient as possible. You know, the other thing is I don't believe that at this point in time we should be storing everything on the blockchain. It's just not efficient. You know, quantum computing could potentially change that. Some of the other models, consensus models, and the Lightning Network, and some of the other things could potentially change that. But right now, I think if you're really doing these things right, you're going to start with a hybrid model, and as the technology improves, then you might shift that more over. And I caveat that with saying there probably are some use cases that are so, you know, limited as far as data is concerned that you could probably do the whole thing in blockchain. But I think if you're going to do a real serious enterprise application, my opinion is you're going to want a hybrid model today. As technology improves, the propagation of the nodes gets better, faster, more efficient. You know, we'll be able to put it everything. So just to kind of wrap this up, so the contract was created we have the get and the set methods, which we've defined over there, right? So I'm going to just go ahead and set a number. So I'm just going to put in the number 54. Why not? And I hit set. Again, I'm getting charged for a transaction. You can see that it's a lot less than it was to create the contract, but I am getting charged. So I'm going to go ahead and hit submit. Again, pending transaction. It's going to take a couple of minutes for that block to get mined and then actually be appended to the blockchain. Once that's done, I can hit get, and that 54 or whatever I put in there will be stored on the blockchain. And we'll come back to that because I know I'm consuming a lot of time here, so I just want to wrap up. I'll come back to Remix in a moment. Just put this slide together because I think it's important to show you what companies are backing blockchain. This is the Enterprise Ethereum Alliance, which is a group that was put together to kind of promote standards within Ethereum and blockchain. And as you can see, there's huge companies that are backing this right now. So I firmly believe this is here to stay. I think it's a revolutionary technology. I think we're in the early stages of it. I think you folks are all on the ground floor. There's a ton of opportunity out there. And I hope that all of us can find a way to make some money on it, because that would be great. Let's go back real quick to up there. Let's see. So just to wrap this up, okay, it was sent. And now if I hit get, you can see it's an unsigned int, and the value is 54. Now that didn't take any time to come back because that didn't actually have to go create a block. That just read it back. So it's instant. Okay. Let's see, I think I'm on my final slide here, and then we can wrap for questions. So some of the obstacles, scalability, we talked about that a little bit. The efficiency, I talked to you about the Ethereum DAO hack. Actually, I covered most of this already. Lack of regulation is one of the areas that we're still short on. The purists will tell you they don't want the governments to be part of this at all. I think that that's going to be an impossibility. It would be nice, but as you can see already today, the governments are trying to get their hands on this and really try to figure out how to harness it so they don't lose their foothold. Future of the blockchain, we talked about the purists and the realists. Cryptocurrencies are definitely here to stay. I do think this will eliminate some jobs, but at the same time, I think it'll create other jobs, like many of the technologies that we've seen. Redistribution of wealth. Well, a lot of very rich Bitcoin people these days. Will that actually come to fruition? I don't know. That's another one of those battles between corporate America, not only just America, but corporations, large entities, and this kind of purist movement that's trying to put the power in the hands of the people. I think it's going to be a battle. I'm not convinced who's going to win one way or the other. I think in the short term, at least, there's going to be a hybrid model where the governments are going to embrace it, and what happens down the road, I don't know. I mean, I don't have a crystal ball, but it's interesting to think about. Do we need a conceptual paradigm shift as far as the way we do business, right? That may be something in the cards in order to really kind of maximize this technology. Right now it's a bartering system where we pay using fiat currencies. Maybe there's some new paradigm that we haven't even thought of, and I'm not claiming to have thought of it, but I kind of think to myself, I think about blockchain, and I say to myself, yeah, we can apply it to the current paradigm that we have, but if you read the Satoshi's white paper and you think about the purist view, maybe we do need a paradigm shift as to how we handle business. And maybe there is a better way for us to do it. Be interesting to see. So that's pretty much it. I know I ran a little long, but time for questions. If anybody has any questions, put up my contact information. I've got cards if anybody wants. You're more than welcome to reach out to me. I have a blockchain consulting firm that does software development, so happy to talk to anybody. I saw a question over here.
Yeah, can you talk about the hybrid model?
Yeah. So the hybrid model being centralized and decentralized, right? So we talked earlier about the different network models, right? And the client-server model with that central server, and then the peer-to-peer models. I think right now, in a lot of, especially like CryptoKitties and some of these other platforms that are on the blockchain, they have a centralized database and website. But they submit certain pieces of data to the blockchain. To me, at the current state the blockchain is in, that is the best way to do it. Because of the efficiency of it, or the lack of efficiency right now. You saw how long it took for one of my transactions to complete, and that's on a test network, okay? Granted, the Ethereum network's much faster than the Bitcoin network. It can take up from 10 to 15 to 20 minutes on the Bitcoin network to process a block. On the Ethereum network, it's probably sub 5 minutes or so. But it's still kind of, if you think of, the amount of transactions like American Express does in a second, it's like 80,000 or some god-awful number of transactions that they do in a split second. This technology's got to improve in order to, really compete there. So having that data in two different places, I don't think today you're going to get the same efficiency that you have from a client server model, from pulling data back and pushing data in, that you would on a blockchain. Does that make sense?
So what would you put on the blockchain? What would you centralize as a hypothetical?
Sure. And somebody asked me, it might have been you earlier, and I did come up with a scenario, and that's because I'm from the healthcare space. Nurse Susie goes into a room and has to administer a medication to some patient, right? She thinks she has the right medication. She administers it. Patient dies, okay? Now Nurse Susie, or whatever I called her, is freaking out, and she now goes back into the system and tries to edit the system. I can tell you this happens. This has happened, okay? I have been in big hospital organizations where I know these types of things have happened. In the blockchain is an append-only database. So for her to change that data would be next to impossible. I wouldn't store her name. I wouldn't store the patient's name. I wouldn't store, different things, a variety of different things that could be stored in a regular database, but I would store the timestamp, which is already inherent in the blockchain. You don't have to actually store that. But I would store the medication. I would store the ID of the nurse. I would store the ID of the patient. Okay, and that's simplistic scenario, but that's a pretty solid one. Of course, there may be other things that you want to put there, but that way anybody can come back and look at that blockchain and know that this nurse gave that patient the wrong medication. Please.
So would you say in summary, you would put the stuff that you want to be immutable in the blockchain?
Yes.
And everything mutable
Correct.
elsewhere?
That's correct. That is correct. And then you also have private blockchains too. That's a whole different topic.
How would you divide between what goes on the public blockchain and the private blockchain?
That's right. And again, I mean, it really depends on the scenario. Some of the other private blockchains are a lot faster as far as mining, or not mining is not the right word, but actually completing transactions. So you really have to take, what's that?
The consensus algorithms.
Yes. And you really need to take all that into consideration when you have a project in mind and how you want to code it and put it together.
In your own firm, have you guys used stuff like Hyperledger and React together, where React is pulling from Hyperledger?
It's funny you say that. We have not used Hyperledger yet. We are looking into it. We have used React against the Ethereum network.
How'd it work?
It's fine. It's tricky. It's tricky to get that tie-in together. I think right now, it's early days. I think there's going to be some tools that need to be made that will simplify some of those things. But it's doable for anybody that's knows how to code. It's definitely doable. Yes, sir.
Technical questions. Can the the program ever do access outside to the internet? Can it check an API itself?
Can a Solidity contract check an API?
Or hit it?
Yes, actually there are events. I showed you in the ERC20 token. There's events that get triggered.
Okay.
I haven't actually done that, I'll be completely honest with you, but I know that those events get triggered, and there's got to be a way to do those. What's that?
Oracles is what you're looking for.
Yes.
Oracles pull information from the real world and you can implement them into your API.
But who starts the transaction?
The event.
Right now, we haven't really found the single best way to do it, but there are a few solutions that try. So one is a company / organization called Oracleize. And what they do is they can't guarantee that the data you're looking for is accurate. All they can guarantee is that this is what the website said at this time, using a block, right, part of the hash from the Ethereum block. So we can guarantee the website said this at this time, and we can put that proof in the blockchain so that your own contracts can check that. So when you write your smart contracts, you predefine what outside APIs you're looking for so that it can do the proof of authenticity for that website at that time.
But that's anybody putting their hands into the Ethereum computer. I want to know, can the Ethereum computer by itself check out?
It cannot. So the only way to do it is through oracles.
Okay. When does the program run?
When does it run?
Yes, does it run one time? Does it run at a particular
Whenever it's
time?
called.
of the day?
Whenever it's
It's on
called,
the
that's right. It's,
I know, but can it start by itself? Go and say.
Yeah, something has to trigger it.
that's right.
So, because the thing about it is, okay, let's put a bookie, right? That's, to me, the first thing I thought of is a bookie. I'm gonna check who won the Super Bowl, and I'm gonna give the person the side that chose the right side.
Your checking is the...
Is the event, the trigger.
Exactly.
Yep.
Yeah, but who checks? So the Ethereum program cannot check by itself.
No, it's when a transaction gets submitted is usually when something gets fired off, or, I mean, that, again, you come into that hybrid model where you might have some sort of service that polls or...
Right.
Your question is exactly what oracles do.
Yeah, but the question is, where does the Oracle live? Because if the Oracle lives outside, then you're trusting still me, so
Now that's,
why are you
now,
going to
it
either?
depends now, there are some other ways to do it. Like for example, if you use something like Counterparty, right? Have you heard of Counterparty?
Yeah.
Counterparty is essentially the Ethereum virtual machine, but it runs inside of Bitcoin. And essentially what it is, you have a Bitcoin node in the center, and then Counterparty is basically a Bitcoin node plus some other stuff around it. This other stuff around it could do what an Oracle does, and then you have to tie in the wallet of that full node. So there are ways to programmatically do what you're wanting, but they get quite complex, and then you have the trust issue of, okay, why that node as opposed to a series of nodes that agree on what an Oracle says.
Yeah, whenever I hear an outside computer, I'm like, just hit the outside computer, right? If I'm going to be the bookie and what?
Well, they're all...
Well, do you trust the API you're pulling from? Do you trust NFL.com?
It's the idea of this is that, my website, for example, is on GitHub pages. You can check what's running on the webpage. There's never a time that that wasn't what's running.
Or you can do the same
You can
thing.
trust
Well, you can
that.
do the same thing with Ethereum as well. I mean, that's all open source also.
So the
contracts are all...
The contract is out there, but if the contract requires that outside trigger, there's that missing component that would be ideal
If
for
it
it to
requires
have.
it, yes. Yeah.
Correct.
Right, that I could
Yep.
go and say, on the 14th of July, just start, run through your code, hit the internet, check the Google API, check the Yahoo API, something we all trust, because you can see which API I'm saying, because the code is there. And then, boom, make a decision based upon that.
But do we trust it? Do you really trust it?
Well, that's sure, because it's out there for everybody to see, and it's immutable.
Not
the contract is
Google.
immutable.
Not Google. I mean, think about the censorship and some of the things that go
Oh,
on.
no. You can go ahead and say, we all trust that that's going to be the API. And
Yes.
if we're all trusting that Yahoo Sports has the correct price, and we all trust that on the day after Super Bowl, that's going to be the right price. And if they're lying to us, okay, SOL, So,
Well, that's-
I mean, the Saul's up there. And but at least I can go and say, I know where that's happening. I know that no one at the last minute is going to change that API and go to their own web server and pretend that the other guys won, because they're losing money otherwise, right?
No, I understand what you're saying, and yeah, it's an interesting topic because you come from this trust model to this untrusted model, which is kind of
Sure.
what the blockchain is all about. And I think a lot of those things are going to have to be hashed out. But I think, and it sounds like you, and I don't know your name, but it sounds like you have a lot of knowledge about it, which I like. I'd love to talk to you. Putting those hooks back and forth is still, I think, an evolution. It's maturing still. And I think that'll get better over time. I think the tools themselves still need to get better. It's not super difficult, but it's not as easy as programming in Visual Studio with .NET. You know what I mean? So, yes.
How do you add Slack into a contract? Like, for example, like fantasy sports model, they update, they revise the stats for certain players. So if you have a DAO, it's a fantasy league, day one, you paid the winner of the fantasy league, but then in 3 days later, they update the stats, and that, some running back had less yards than originally reported. Which already paid off 2 days ago. Like, what's the mechanism to create slack in that situation?
I think that comes down to the contract itself, right? And putting that logic in the contract, and if the stats change, first of all, you're gonna have to think from a company policy perspective. How do you want to handle that, right? And depending on what you define, you can either put that into your contract or you can end that transaction when it's committed. Obviously, I wouldn't do that in your particular scenario because you'd have a lot of pissed off customers. So I would think you would probably put that logic within the contract itself. And if those stats change, there would be a call out to that contract that would redistribute that.
So after you've already paid off the winner of that weekend, you can go back and
Sure, you can go and take money and put money. Yeah, I mean, you have to have permission by that person, but it's something you'd have to write into the contract. And maybe it goes into an escrow account for some period of time before it actually gets transferred. That's actually the way you would do it, because once it gets to the person's account, forget it. You would probably put that in an escrow account temporarily, wait for some period of time to see if anything changes, and then pass that along.
Yeah, and just commenting on how data changes, doesn't change. Like, this data changes all the time. Like even like NASDAQ and New York Stock Exchange, every day they're issuing updates of long prices from previous periods.
Yeah, don't even get me started. I mean, we could get into a whole philosophical conversation about capitalism and who's pulling what strings and modifying what data, but that's for another time over a beer maybe. All right.
Question.
Yes.
How are the smart contracts utilized when people are launching ICOs? Is that for just receiving the funding?
So that's an interesting question. So a lot of the ICOs are created using Ethereum because you can actually create coins using that ERC20 standard. So that would be actually created on the Ethereum platform. And I'm not sure, what was the rest of your question? Did that answer it, or?
Yeah, like, because I know, like, when you do ICO, some people, like, you can distribute or you can receive via Bitcoin or Ethereum or both. But you have to use the smart contract.
You could use those to distribute the actual ICOs as well if you wanted, absolutely. That's how you would do it, through the smart contracts and the logic through the smart contract.
So
Yes.
that same, just to elaborate off of that, so you're saying that there can be more than one smart contract within that ICO or that balloon, so to speak. So once the funding is there, tokens are distributed, then you can go into the next smart contract to start actually building a utility.
Sure, you could absolutely write another smart contract that would interface with that token.
And that same address and everything, so.
Yeah, I mean, the addresses you could plug in, excuse me, you could plug into those contracts and send them, right? You need a to and a from address. It's very simple. So, that can be plugged into any smart contract.
Right.
Anybody else?
I got one.
Okay.
I'm still kind of fuzzy on how the decentralized apps work. So
Okay.
how is the application decentralized? So the client files live on a server, I imagine, or through IDFS, you provide a file or something.
Right.
But what part of that is decentralized? The data? Is that
No, the actual contract as well is
So
decentralized.
like the CryptoKitties example,
Mhm.
that's the hybrid model.
Right.
So what part of that exactly, I know you mentioned it a little bit before, but what part of that exactly is decentralized?
So,
The particular data that they put on the blockchain.
right, so, I'll be quite honest with you, I haven't read the white paper in full, but I can take some guesses at it. I would say probably some of the images and things are not stored on the blockchain. The value of the CryptoKitties themselves will probably be stored on the blockchain. Who they belong to will be stored on the blockchain.
Transaction data still.
Yeah, it's really, I think that's one of the best use cases for it is financial transactions and being able to keep track of that type of thing.
To piggyback off of that,
Yeah.
how do you exactly store, where do you store these apps? Are they stored on AWS, Azure, like how
The
does that?
miners.
Yes,
The
so the
miners-
nodes on the
miners that
network.
mine Ethereum.
Correct.
Your friend with video
So
cards.
when you're creating the actual cryptocurrency or the coin, you have to count on a miner?
So when I just submitted it earlier in Remix, it went out And the miners on that test network actually had to mine that block, and then it was stored on the blockchain, which is distributed amongst all the nodes on the network. Does that make
But
sense?
that has to be an outsourced thing, that can't be brought in-house.
It can be. There are.
That's the under 51%.
No, hold on.
No, he's talking. No. He's talking about.
Is it on a server that's out there, or is it on? Think of it as
Every miner.
In-house is your program running this. This is out on the network. There's not one place where it is. It's in everywhere.
But theoretically,
How do you secure that?
so to your question, you have public and private blockchains. Okay,
Right.
the ones we've been talking about are predominantly public.
Okay.
Okay. You have your private blockchains. Hyperledger is one of the kind of the premier open source blockchains that is really kind of doing really well in that space. But it's more of a closed network, so only people that have permission to get into that network can access it. Okay, and there's ways to do that with Ethereum too. But again, it's what do you want to store on there? You have to really consider all of that. Yes.
Now you're saying with the test case, you're able to just get test Ethereum, just in the test network.
Yep.
So are there miners plugged into the test network that are devoting their resources to create test Ethereum? Do they get valid Ethereum?
That's a great question, and I don't know the answer to that.
They don't have the money. Yes, people want to test it.
It's just, why would you do that?
Because they realize the value of having somebody having a sandbox to play with their content.
No, I get that, but you're spending money on power.
Community service.
Yeah, but think about it long term.
Literally
Right? If
community
you're
service.
back home in theory, then you
cause.
want a robust test net so somebody can write something that actually works on the theory.
No, I agree with that, but what incentivizes the average person to actually spend money on a computer, spend money on power for a test network? I would think
Probably not average.
It's not the average person.
Well, that's true.
It's some of the tutorials that I was watching, in development.
Oh, really?
You're participating, just.
That makes perfect sense. You using you have to devote your resources.
Yeah. Yeah. Well, I just use the faucet. That's been the easiest way for me, and
Or the test RPC for
The
it.
miners
well, yeah.
Well, the miners do the computation needed to add the new blocks and stitch them on the chain, and they get rewarded with the currencies.
All right, one last question right back here.
Yes, Ron.
It's a simple question, like, you said every transaction,
Did you say simple? You said
every
simple.
transaction
You don't
costs.
say that to a programmer, by the way.
Every transaction costs something, and you put it up on
Yes.
blockchain, pick it up. Who gets paid?
The miner.
The miners.
The miners.
Oh, so the miners are getting
Yeah.
paid
That's
for
correct.
each transaction, all right, so it's.
Because they're doing the work for us.
Yep.
That's the incentive, but on the test net, there's no incentive. They're just getting more test net coins.
So Jason, thank you very much for the presentation today.
My pleasure. I enjoyed it.
Real quick, we have some announcements, but before I do that, I want to bring up Dave and Brittany from Focus Global Solutions, and they're just going to introduce themselves and what they do. So there's a lot of people here that they might be able to help, or